All right, hello everybody. You have made it to the final lesson of Unit 1 for AP Chemistry, and it is on valence electrons and ionic compounds. So today's objective is to explain the relationship between trends and the reactivity of elements and periodicity. Our goal here is to connect periodic trends with reactivity. So whether two elements form a bond is going to depend on their valence electrons and how they interact with the nuclei of the atoms. And that's why electron configuration is so important. So elements in the same column of the periodic table are usually going to behave similarly, which means they're going to tend to form compounds that look and act alike. So that's going to be really important for this lesson. Valence electrons are the electrons in the outermost shell of an atom, and they're the ones that actually take part in chemical bonding. So elements in the same group of the periodic table all have the same number of valence electrons, and that's why they tend to form similar compounds. Typical charges in ionic compounds come from where an element sits on the periodic table, because that tells us how many valence electrons it has. So the first question, why do elements in group 2 tend to form a +2 charge when forming compounds? Well, that's because group 2 elements have 2 valence electrons. It takes less energy for them to lose those 2 electrons than to gain 6 more, so they tend to form a +2 charge when bonding. And then the second question says, why do elements in group 17 tend to form a -1 charge when forming compounds? And that's because group 17 elements have 7 valence electrons. They only need 1 more to complete their outer shell or their octet, so that they just gain 1 more electron, and that is an extra negative charge. So that's why it has a -1 charge. And before we move on, I want to go over a few things on this periodic table here. Number 1 is that we are showing positive and negative ions. Remember, positive ions are known as cations and negative ions are known as anions. And what I want you to really think about when we're forming ionic compounds is you have to have 1 cation and 1 anion. So we have to have a positively charged ion and a negatively charged ion. So when you're looking for ionic compounds, just remember you have to have a metal and a nonmetal, because your metals are going to be your cations, your nonmetals are going to be your anions. Another thing I want you to look at are your 3 transition metals that are here. Sometimes AP Chemistry will give you one of these 3 metals without a Roman numeral. That's because they don't need a Roman numeral, because they only form 1 charge. So silver will always have a charge of 1 when becoming an ion, and zinc and cadmium will always have a charge of +2 when becoming an ion. So those are 3 that I would like you to memorize. And remember, ionic compounds form when atoms transfer electrons. So when we get into later units, we're going to talk a lot about covalent molecules. Those are when atoms are sharing electrons. In these ionic compounds, they are transferring electrons. So they're either getting rid of an electron or accepting an electron from another atom. And once these atoms either give up or take an electron, they now have a charge. And those opposite charges in an ionic compound are what are keeping them together. That's the ionic bond. And that is also known as an electrostatic attraction. So let's do a brief overview of how to name ionic compounds, just in case you are unfamiliar or just don't really remember from your previous chemistry course. So when we're naming ionic compounds, remember the first thing you're always writing is the cation. That's always written first, and then you're going to write your anion. When you're writing the name of your cation, you're just using the element name. So if we have NaCl, the cation is just sodium, you're writing down sodium. And then when you write down your anion, in this case we have chlorine, you are just changing the ending of the element name to IDE. So instead of sodium chlorine, it would be sodium chloride. A few exceptions to this is if you ever have a polyatomic ion, you're never changing the ending of that. So for example, if we had sodium sulfate. So we have sodium with a positive 1 charge, and we have sulfate with a 2 minus charge. When we are writing this down, we're not changing the ending of sulfate. It will just be sodium sulfate. So when you have a polyatomic ion, you are not changing the ending of that. And then the other exception is with transition metal cations, it's going to be followed by a Roman numeral, and that Roman numeral is going to tell you the charge of the transition metal because it can have different charges. All right, so let's do some practice on naming ionic compounds with polyatomic ions. So the first one we have is ammonium sulfate, and if you want to practice these on your own, go ahead and pause now and then restart. So ammonium is NH4 with a positive charge, and sulfate is SO4 with a 2 minus charge. So remember, in ionic compounds, there is going to be no overall charge, so you want to balance out the charges. So since we have a 2 minus, we need 2 positive charges to balance that out. And whenever you need multiple polyatomic ions, just remember, put that polyatomic ion in parentheses and put the subscript on the outside of that parenthesis. Next up, we have aluminum cyanide. Aluminum is an element which forms a positive 3 ion. And then cyanide is our polyatomic ion here. It's capital C, capital N with a negative 1 charge. So again, we want to balance out the overall charge, so we need 3 cyanides. So we have aluminum with a positive 3 charge, and we want to balance that out with 3 cyanides. So we're going to put cyanide in the parentheses. And then the last one is calcium chlorate. So calcium is in group 2. It will form a positive 2 charge. Chlorate is ClO3 with a minus 1 charge. So we need 2 of those chlorates to balance out that positive 2 charge. So our formula would be Ca, ClO3 with a 2 on the outside. And then we have some with our transition metals. So I really wanted to put zinc and silver in here just so you can remember that you do have to memorize those charges. So zinc will always have a positive 2 charge, and sulfate is SO4 2 minus. So since they have the same opposite charge, they're going to balance out. So we just have ZnSO4. And then remember, silver always has a positive 1 charge, so we're going to put that there. And then phosphate is PO4 3 minus, so we need 3 silvers to balance it out. Silver is not a polyatomic ion, so we do not need parentheses. So silver 3, PO4. And then finally, iron 3 sulfate. Whenever you have this Roman numeral here, just remember that that goes immediately to the cation. So this iron has a positive 3 charge, and sulfate is again SO4 2 minus. So we want to balance out to 0, so the common multiple will be 6. So we're going to need 2 irons, and then we're going to need 3 sulfates. All right, let's practice a free response question. So it says element X has the electron configuration above. What is the formula for the compound formed between element X and chlorine? So here element X says it ends in 3p1, so we're going to go to the third energy level. We're going to go to the p sublevel, and it is the first element, so we know element X is aluminum. Now when aluminum forms an ion, it has 3 valence electrons, and because it has 3 valence electrons, it's much more likely to lose 3 than to gain 5 to form that stable octet. So when it loses those 3 electrons, it's going to have 3 extra protons, which is why it has a positive 3 charge. And then it says it's going to form a compound with chlorine. We know chlorine is in group 17, so it has 7 valence electrons, which means it only needs 1 more electron to be stable, which is why it has a negative 1 charge. Now if we're forming a compound, we have a 3 plus charge and we have a negative 1 charge. So we need 3 of those fluorines to balance out our ionic compound. So it'll be AlF3. A student claims that a compound with sodium and fluorine and a compound with sodium and oxygen will have the same formula. Do you agree? Well, let's look at these two options. So first we have sodium and fluorine, and then we have sodium and oxygen. So same cation, different anion. Now looking at these two anions, we know oxygen forms a -2 ion and fluorine forms a -1 ion. So just based off that fact, we know that these formulas are going to be different, so we do not agree with the student. So you would say something along the lines of, I do not agree. Fluorine forms a -1 ion, while oxygen forms a -2 ion, making the formulas NaF and Na2O, which are very different. And then the very last slide of Unit 1 says, which of the following are likely to form an ionic bond? And as simple as this sounds, it's pretty common on the multiple choice section, so I want to make sure that we have this locked and loaded for the exams. So when it's asking for ionic bonds, it has to be between a metal and a non-metal because it has to be between a cation and an anion. So when we're looking at potassium and oxygen, potassium is a metal in group 1 and oxygen is a non-metal in group 16. So yes, that would form an ionic compound. Then calcium and sodium. Calcium and sodium are both metals. So sodium would form a +1 ion. Calcium would form a +2 ion. So those are both metals, cannot form an ionic bond. And then we have potassium and bromine. Potassium's in group 1. Bromine's in group 17. So that is a +1 ion and a -1 ion. That would form a great ionic compound. Okay, I hope this video helped. If you have any questions, please feel free to ask. I hope you have a great day. Bye.